Hello.
Hello.
Hi Diksha Didi, good evening.
Hi, good evening.
Alright, so today we are gonna continue with our if conditions, the decision making in C++ chapter. So let's just
Okay.
continue with it. Right, so over here there can you see my screen?
Yeah, it's visible.
Alright, so we read this much part where we just saw why we need decision making. Like in real life, we need to make some decisions on certain conditions. Similarly, in programming, we may have to make some particular decisions on some condition, right? So that's where our if else, nested if else if, and all of these conditions come in, right? So now we are on types of conditional statements in C++. Right, so let's just open this. All right, so over here we have if else, we have the ternary operator, so this is called the ternary operator, right? And then we have the switch statement, right? So in if else we have if, the only if, like we have the if condition only. So we say if some certain condition is true, then it will go inside the block of code and execute that code, else it will just ignore this block of code. Then you have if else, right, where if some condition if the condition given in the if statement is true, then it will go in the if block and execute those statements. Else if this is false, the condition given is false, it will go in the else block and execute the code that is there in the else block. Then we have if else if, where we are checking for some condition. If something the condition 1 is true, then we'll go in the if block and execute the code inside the block. Else if, so if this condition is false, then it will when we give an else if, it will go in else if and check the condition 2, right? So it will check a second condition, and if that's true, then it will go inside the else if block. Or else it will just if none of if the condition 1 and condition 2 both are false, then it will just go in the else block and execute the code in the inside the else block. And finally we have nested if, where we have condition 1, right? So if we have condition, if condition 1 is true, then it will go in, and over here we have another if condition inside, and inside a condition. So when we have another conditional statement inside a conditional statement, then that's called nested if. So like if inside of an if is nested if, right? Next type of conditional statement is the ternary operator, where you give a condition over here, and if it's true, then this the part of code that you give, the single line that you give over here is gets executed. If it's false, then the part over here that you give is executed. And finally, the third type of conditional statement in C++ is the switch expression. So over here in switch, what happens, you over here in switch you give an expression, like for example 1, or let's take 2. So if then you in that you have to give cases. So if the value of expression is the matches the value of the case, like if yes given switch 2 and case 1, so 2 is not equals to 1, right? So it will ignore the block that we'll give in this case, right? Then it will go on to the next block, right? And it will check case 2. So if the expression's value is 2, right, then and over here in case we are giving 2, right? So both the values are matching, the expression and the case that we give over here is matching, so it will go inside the case block, it will execute that code, right? And then it will break out of the switch expression, right? And we also have a default block. If none of the cases match with the expression, then the default block is executed. So all of these conditional statements we are going to see in detail today in this class. So we have the if statement. This is the table of contents. So we have the if statements. We have the if else statement, nested if statement, if else if ladder, the switch statement, conditional operator, and we have the jump statements. So we have already done break, continue, and return. We'll learn something new today. That's go to, right? So the go to jump statement will be new for us, right? That we have not already done in the basic course. All right. So now let's just start with if in C++. So the if statement is the most simple decision making statement. So it's the most simple decision making statement. It is used to decide whether a certain statement or block of statements will be executed or not. If a certain condition is true, then a block of statement is executed, otherwise not. So when you give, you just use the if statement. Then here's the syntax: if condition. So if this condition you give over here evaluation true, it will go in and execute the statements that are given over here. If it's false, it will completely ignore this and then go on executing the code normally. So here the condition after evaluation will be either true or false. The condition will always be either true or false. So in C++, so over here, one thing I'll mention that over here, the website is using C everywhere, as decision making statements are both same in C and C++, right? So wherever C is written, that means C++ only, right? So this is the decision making statements that we are seeing over here is are used the same way in both C and C++, right? So the C++, we'll just say wherever we see C, we're just gonna say C++. So the C++ if statement accepts boolean values, right? So it will accept boolean values, right? So if the value is true, then it will execute the block of statements below it, otherwise not. So if you do not provide the curly braces after the if after this, if you don't provide the curly braces, then by default if statement will consider the first immediately below statement to be inside its block. So here's one new thing that we have seen, that if you don't provide these curly braces, then the statement just after the if condition will get executed if the condition is true, right? So we are going to see that example. In this example we are going to try it out, but first we are going to see the flowchart of the if statement. The condition, first it goes and checks the condition. If it's true, right, then it will go and basically go inside the if condition if block, right, and then it will normally execute. If it's false, it will just skip the code that is there in the if condition and it will just continue with the program, right? So here we have an example of using the if statement. So we are defining I equals to 10. We are checking if I is greater than 15. So we are logically checking if 10 is greater than 15. Now we know 10 is not greater than 15, so this whole thing will return false. Now because it's returning false, it won't go uh, inside this if statement, and it will just ignore this block of code and it will execute normally, right, and it will continue the execution. So it will just show I am not in if. So if we run this, it will show I am not in if. Alright, so it's showing I'm not in if. Now we're gonna test it without the brackets. Let's say I is 20. So now this should be true, right? So the condition is true, right? So if the condition is true, now we are not giving any brackets, right? So the condition just after the if statement will be considered as it is in the if statement, right? So now it will just show us 10 is greater than 15 and I am not an if. Right, so we are getting 10 is greater than 15 and then we are getting I'm not an if, right? So if we say over here 10, right, so 10 greater than 15, it will check that is false, so it will ignore this whole thing, as the condition just after this if statement is considered as it is part of the if statement. So this part is ignored and it will just show I'm not an if. Alright, so we're just getting I am not in if, right? So pretty cool. So as the condition present in the if statement is false, so the block below the if statement is not executed, and when not giving curly braces, the statement below the if statement won't get executed. So is the if statement clear?
Yeah, it's clear.
Alright. So now we have if else in C++. So the if statement alone tells us that if a condition is true, it will execute a block of statements, and if the condition is false, it won't. But what if we want to do something else when the condition is false? So here comes the C else statement. So we can use the else statement with the if statement to execute a block of code when the condition is false. So the if else statement consists of two blocks, one for false expression and one for true expression. So over here, here's the syntax of the if else condition in C++. So over here we'll give a condition in if, right? So if that will be true, then it will go and execute the block of code inside the if statement. If this is false, right, so it won't execute the block of code inside this if statement. It will go in the else statement and execute that block of code. So if it's true, it will execute the if body. If it's false, it will execute the else body. So here we have the flowchart of the if else statement also. So the program will start, it will see an if condition. If that's true, then the if body will be executed. If that's false, then the else body will be executed. And once both the bodies are executed, one of the bodies is executed, then it will just continue with the statement just below the if statement and normally just execute the whole program. So over here we have an example of the if else statement also. Over here we have int I equals to 20, and then we have 20 less than 15. We are checking 20 less than 15. So this is false, so it will ignore the block of code that is there in the if statement, and it will just go and execute the block that is there in the else statement. So over here we are getting I is greater than 15, right? One thing to note over here, we are not giving any brackets, right? So this one condition is considered to be in the if statement, and this one condition is considered to be inside the else statement. Now if we just give some indent and we say see out something else, right, then what will happen, this will not be considered to be in the else statement. This will be considered to be inside the uh, uh, this will be considered to be outside the if else statements. So the if else block is this much only, right? This is its indentation is this indentation kind of tells us that this statement is also inside the else block, but no, it is not inside the else block. Only this statement is inside the else block, and this statement is inside the if block. So over here it will go in the else block, it will show I is greater than 15, and then it will come outside, so the if else statement will get over, right, and then it will come out and show something, right? So brackets are not mandatory if you only have to give one statement in the if and else statements, right? So if you don't have a big block of code and you only have one statement on if and else, then you can then the curly braces are not mandatory. So is this part clear?
Yeah, it's clear.
All right. So next we have a nested if else in C++. So a nested if in C is an if statement that is the target of another if statement. So basically, nested if statements mean an if statement inside another if statement, right? So when you have an if statement inside another if statement, that is considered as nested if statements. Yes, both C and C++ allow us to nested if statements within if statements. Like both C and C++ allow us to have if statements inside of other if statements, right? So we can place an if statement inside another if statement in both C and C++, right? So we are learning C++ right now, so we need not mention C over here, right? So over here the program starts, it checks condition 1, right? If it's true or false, then it will go over here, right? If some condition if it's true, it will go here. Let's just say if it's true, it will go here. If it's false, it will go in the else statement. So now when condition 1 is true, let's take it true, then it goes inside the if block, then it finds a condition 2 because we have another if statement inside that if statement, right? And after reaching condition 2, if it will be true, then it will execute statement 1. If it will be false, it will execute statement 2. So over here we had an if statement inside which we had another if statement. And all right, so this was the basic flow diagram of a nested if else. So here we have an example also. If a condition 1 meets, right, then it will go in and it will check. If condition 2 meets, then it will execute this block of code, else it will execute this block of code. All right, so here we have an example. So in this we have if I is equal to 10. So yeah, that's true because i's value is 10 and we're checking 10 equals to 10. So this will give true, right? So it will go inside the if block. Then it will check if I is less than 15, right? So that is true. So I is less than 15, so that is 10 is less than 15, so it will go in and print I is smaller than 15, right? Next, we are not finishing the if statement right over here. We have another if statement inside this, right? So we have two if statements inside this outer if statement. So we have this outer if statement in which there are two different if statements, right? So this if statement is separate, this if statement is separate inside the uh, like main if statement. So inside the inside the outside if statement, right? So this is a different if statement and this is a different if statement. So this will execute differently and this will execute differently. These two don't have any relation with each other, right? So if I is less than 15, it will print I is smaller than 15, as this is true. Then it will check if I is less than 12. That is also true. So it will just go and print I is smaller than 12 too. If it was not smaller than 12, then it would have gone in else and it would have shown I is greater than 15, right? So over here it will show, yeah, so it is gonna show I is smaller than 15 from here, right? Then it is gonna show I is smaller than 12 too from here. Alright, so next we have the if else if ladder in C++. So the if else if statements are used when the user has to decide among multiple options. So when the user has multiple options, then the if else if statements are used. So the C++ if statements are executed from the top down, right? So first it will check the if statement, then it will check the else statement just after the if statement, then it will check the else if statement just after the if statement, and it will check all the else if statements in order, right? And the else statement will check in if none of the statements, like for example we have if, then we have else if, then we have another else if, and then we have else. So then it will check first for the if condition to be true or false. If it's false, then it will go and check the else if condition to be true or false just after the if statement. If that's also false, it will go in the else if statement, or that is just after the previous else if statement. If that is also false, then in the end, after checking every condition, it will go in the else statement. So this will be more clear with an example, right? So let's just read this part and look at the syntax, and then we'll be able to move on to the example. So the if-else if statements are used when the user has to decide among multiple options. So the C++ if statements are executed from the top down. As soon as one of the conditions controlling the if is true, the statement associated with that if is executed and the rest of the C else if ladder is bypassed. If none of the conditions is true, the final else statement will be executed. So the if else if ladder is similar to the switch statement. So the if else if ladder is very similar to the switch statement that we are going to see further in this chapter. So let's just see the flowchart of the if else if statement. So first it enters the program, it checks for condition 1. If that's true, it will execute the block inside of it, right? And it will just go out of the, it will uh, just ignore all of these condition 2 and condition 3 and all, right? So it will bypass the else if ladder that is remaining, right? But if that's false, it will go on to check condition 2, right? If that's true, then it will execute the statement inside it, and then it will go and just execute go and bypass the remaining ladder. And if that is also false, then it will go on condition 3, right? So the flowchart is a bit wrong over here. If condition 3 was true, right, then it would have executed the statement inside the condition the this else if block, right? But if it was false, then it would have gone to the else body, right? So the flowchart is a bit wrong in this example, right? So we are just gonna understand this with example as the flowchart was wrong. So over here we have I equals to 20. First we are checking if I is equals to 10, right? So that's false. So it will just now go to the else if statement just after this if statement. Then we are checking if I equals to 15, right? This is also false. So it will ignore this part, and then it will go to the else if statement just after this else if statement, right? So now it will check if 20 equals to 20, right? So that is true, so it will just show I is 20. This was the if else statement, right? And if we had it like 25, uh, I'll just edit the code. If we had the value of I like 25, so it would have checked I equals to 10. That's false, so it will go in the next else if. It will check I equals to 15. That is also false, so it will go in the next else if. I equals to 20. That is also false, so it will go in the next else if. So there's no next else if, so it has reached to the else block, else statement. So it will execute whatever is there inside the else statement, that is I is not present. So now we'll get to see I is not present. Alright, so we are getting I is not present. And we have seen the basic conditional statements, that is the if statement, if else statement, nested if statement, and if else if ladder. Now we are gonna move on to the switch statement in C++, and I just want to confirm if everything is clear right till now.
Yeah, it's clear.
Alright. So now we are on the switch statement in C++. So the switch case statement is an alternative to the if else if ladder. So it's very similar to the if else if ladder that can be used to execute the conditional code based on the value of the variable specified in the switch statement. So a switch block consists of cases to be executed based on the value of the switch variable. So over here what we have switch expression. So this expression will be some value like 2, right? Then we'll have cases, right? So if the value we give over here with the case keyword, if that matches the expression, then whatever code is there inside that case, that code will be executed. If that does not match, it will go on to check with the next case, right? And it will keep on checking cases until it matches the expression with the value given with the case, right? And if none of the cases match, it will go on to the default one, and it will just execute whatever is there inside default, right? So note the switch expression should evaluate to either integer or character. It cannot evaluate any other data type. So we're gonna see that, right? We are gonna test that also. All right. So we have this is the flowchart of the switch statement. So we have the switch conditional statement. It will check for case 1. If that's true, then the statements will be executed and it will just break out of the switch statement, right? Then if it's false, it will go on to check case 2. If that's true, then it will just execute all the statements and then break out of the switch statement. But even if that is false, then it will keep on checking cases, and if all the cases are false, then it will go on to the default block, right? And default does not need true. Default will directly execute the statements inside it, and it will break out of the if switch statement, right? So next we are going to see the code over here for the switch statements. So we have integer var equals to 2. We are switching on var. So whenever some case's value is 2, that case will it will go inside that case and execute the code inside that case. So switch var, so we are saying switch 2. So case 1, so 1 is not matching 2, so it will not go inside this case and check in case 2, right? So now case 2, 2 is matching with the expression given over here. So 2 is equal to 2 over here. So it will go inside this case, it will print case 2 is executed, and then it will break. I'll explain why we need to give break in a second, right? First we are just gonna say, like, if it's 3, then what will happen, it will check case 1, that's false, then it will check case 2, that's false. So then it will go, because none of the cases match with the expression over here, it will go inside the default case, uh, and it will show default case is executed. Right, so it's showing default cases executed. Now the question arises, why are we giving break after every case, right? So we need to give break after every case. It's not compulsory. If we don't give break, it won't lead to an error, but the thing is, it will do unnecessary work. Your program will do unnecessary work. For example, your case 1 matches and you don't give break anywhere, right? Then what will happen, your case 1 matches and you don't give break anywhere. So when this matches, it will go in and execute case 1 is executed, right? So it will execute the block of code and it will show case 1 is executed. Now it will now one case has matched, so it will unnecessarily check it with other cases. So it will go to case 2 and check if both of them are same, right? So if we had 100 cases, and if the case first case only matched, then your program would have done unnecessary work, as it would have checked the remaining 99 cases also, when the first case was already matched, right? So when we give break after every case, then when the case is matched, it will go in, it will execute the code inside the case, and then it will break out, we are gonna say break. So break will break out of the switch statement, right? So it will break out of this switch statement, right? So it won't further check any more cases once it has matched one case, right? So that was the switch statement. Now we can move on to the ternary operator. So that is also called the conditional operator in C++. So have we done this ternary operator in the basic course? I believe we haven't.
I don't think so.
Alright. So this will also be a new thing for us. So the conditional operator is used to add conditional code in a program. It is similar to the if-else statement, but it is also known as ternary operator, and it works on 3 operands, right? So it's very similar to the if-else statement, but it's a shorter version of the if-else statement. So what will happen, we'll give the condition. If it's true, then the code given over here will get executed. If it's false, then the code given over here will get executed. So here we have the flowchart also. Over here, when expression 1, if it's true, then the part after the question mark, after the question mark will get executed, right? Right, so whatever expression we give after the question mark, that will be executed. If it's false, then the part after the colon will get executed. So the part of the after the colon will get executed if this is false. If it's true, the part after the question mark will get executed, right? And then the result, we'll get the value of the expression, and then we can save it in a variable. So we are going to see this in action, so that it's more clear for us. So we have an integer var, right? So we are creating an integer variable, right? And then we have also created a flag variable whose value we are setting to be 0, right? Then we are saying variable is equals to flag equals to 0 question mark 25 or negative 25. So now over here, this is the ternary operator. This part is the condition. This part will be executed when the condition will be true, and this part when it will be false. So we are checking flag equals to 0. That will give us true, because 0 is equal to 0, so it will give us true. So the part after the question mark will get executed, that is 25. Now 25 is not like getting executed, it's a return value. So the 25 is getting returned, right? So 25 is getting returned, so var will get 25, right? So var's value will be set to 25. If flag would not have been 0, right? So flag's value like would be -1. Then this would be false, right? So the it will not look at the part after the question mark, it will look at the code after the colon symbol, right? So it will then return this value, so it will return -25. That will get saved in var, right? So var, when flag's value will be something else, not 0 and something else, then var's value will be -25. But if it will flag's value will be 0, then var's value will be 25, right? After that we are just printing the value of var when flag is 0, right? So we are just printing the value of var when flag is 0. Then we are changing the flag to 1. Then we are giving the same ternary expression over here, that flag equals to 0, that is false, so it will not go over here, and it will go over here and return this value and set the value of var to be -25. Then it will show value of var when flag is not 0, and it will show the value of the variable. So first we are gonna get the value of var when flag is 0, and we are gonna get 25. And then we are gonna get value of var when flag is not 0, and we are gonna get -25. Alright, so we are getting value of var when flag is 0, 25, and value of var when flag is not 0, -25. So is the ternary operator clear?
Yeah, it's clear.
Alright. So next we have the jump statements in C++. So these jump statements are used in C or C++ for the unconditional flow of control throughout the functions in a program. So they support four types of jump statements. So C++ has four types of jump statements. We have break, right? We have continue, right? We have go to, right? And we have return. So we're gonna see all the jump statements one by one. So first we have break. So this loop control statement, so this is a loop control statement that is used to terminate the loop. As long as the break statement is encountered from within a loop, the loop iteration stop there, and control returns from the loop immediately to the first statement after the loop. So over here they are saying that when you give the break statement in between the loop's execution, so the loop will stop there and then, and it will just not continue with the loop, and it will go outside of the loop and continue with the normal execution of the code, right? So it will continue executing the code like so. The loop iteration stops there and then wherever you give break, the loop iteration stops there, and the control returns from the loop immediately to the first statement after the loop, right? So we can see the example also. So basically the break statements are used in situations where we are not sure about actual number of iterations for the loop, or we want to terminate the loop based on some condition. So over here there's a flow diagram also. So first the loop condition expression, right? So if that's true, then the loop code block is executed, right? And it can go back to the condition expression, and the loop code block can be executed. Inside the loop code block, if there's a break statement, then it will directly go to the statement after the loop block. And once the condition expression is false, then also the same thing will happen. So either by breaking from using a break keyword to break out of the loop, or the condition of the loop being false, it both will lead you to the statement after the loop block. So it will be more clear with the example. So we have a find element function we are creating over here that will be accepting an array, right? Its size and a key, right? So first we're going to see the main method, and then we're going to see the find element method. So in main we are creating an array of 6 elements, an integer array of 6 elements. Then we have an n value of 6, and we have key 3, right? So we are saying find element array and key, right? Inside we are looping on the we are saying for int I equals to 0, I less than size I plus plus. So we are saying I equals to 0, I less than, and we are giving the size 6. So I less than 6, I plus plus. Then it is going in, it will say if array I is equals to key. So the key value we are passing 3. So if the array's element is equals to the key value, then it will go in right, it will print element found at what position, and then it will break out. So over here, let's look at let's just see how is this working. So first it will say array 0. It's the loop is starting from 0, so array 0, that is 1, is equals to key. So we're checking 1 is equals to 3, that is false. So it will go back, so there's nothing else, so it will go back, it will increment the value of I, right, and it will check this condition, right, that we have seen how the loops work. And then it will check array I equals to key. So we are checking array 1 is equals to key, so array 1 is 2. So we are checking 2 equals to 3. That's false. So it will go back. It will increment the value of I. It will then go check. So array 2. So array 2 is 3. Right. So array 2 value is 3. So 3 equals to key. This will be true. So we'll go and it will show element found at position I plus 1. I is the index and indexes start from 0. So that's why they have added 1. Right, to tell the exact position. So exact position is 1, 2, 3, right? But its index is 2, right? So this element's position is 3, but its index is 2. And if we would have printed I, we would have gotten its index and not its position. So its position we are getting from I plus 1. So element found at position 3. So the element we wanted was found at position 3. So that's why it's showing element found at position 3 over here.